Good day, my name is David Ronin Reyes of Group 4 CPE 107L B2. Now for today, I'll be discussing Lab 2 activities, particularly question 5, 6, and 7. And let's get started by opening our Logism app and our given. Now I've already prepared this. So since we have our question number 5, we could start. So for our question number 5, we are asked to implement the following came up in Logism using SOP. And however, through analyzation, we could see that our given is in POS. Now, in order to change that, we just simply change these variables that are uh, left blank to high frequency. So how could we do that? We do that by simply placing the value 1. So I've already done that, and we have this table, new table in the POS. Now, we start by grouping the ones by 2s, by 4s, or by 8s, never by 3s or 5s. So I'll start off with this green group I've already created. So as we can see, from the left we have WX, and from the upper we have YZ. Now comparing the values, we start by comparing 0, 0, and 1, 0. Since these are the two areas covered by the green group. So comparing 0 for W and 1 for W, since both numbers are changed, we get the value, we get to omit the said letter. Now moving on to X, we get 0 and 0, which are the same, so we put the letter X. However, 0 is different from the one we have in the figure or in the group, so we add X. We add a prime, so it's X prime. Now we move on to YZ. Since again we covered this part by the green group, 0, 1, and 1, 1, since for our Y, 0 and 1 are not equal, we simply omit Y, and now we compare Z. Since Z is 1 and 1 here, we put Z, then move to next group, but before that we add the symbol plus. Now we move to the yellow group, which is these groups here. Now since we only have them in one row, we could say that W is equal to 0 and X is equal to 1. So we put here W prime X. Now we move to our YZ and compare them by column to column. So 0, 0, and 1, 0. For our Y, we have 0 and 1, and since it has changed, we simply omit it. And since 0 remains as 0 and 0, we simply put Z prime. Then plus, move on to the blue group. And since the blue group is covering all the columns of YZ, we simply omit YZ. And only compare WX, which is here. And since there is no other values covered by the blue group in this column, we simply put W for 1 and X prime for 0. Then proceed to the last group, which is the orange group. So the orange group covers these 4 values. So we simply compare 1, 1 and 1, 0. So 1 is equal to 1, so W. And then 1 is equal to is not equal to 0, so X is omitted. Now we compare YZ. 0 is not equal to 1, so Y is omitted, and Z is equal to Z, so we put WZ. Now let's compare it to the given here. I'll just copy this. Control X. I'll just cut. Control. Now we've done it correctly, and here is the truth table for that. But before that, let's create it using Logism. So I've actually laid out the inputs and the ICs we'll be needing for this project. So let's look at the variables we've got again. So we've gotten these values, and in order to see, we should look at the process it has gone through. So we've been needing a NOT gate, an AND gate, and a OR gate. So I have actually placed one NOT gate here. Now let's start by looking at the values or the letters we'll be using. And since Y will be not using the input Y, I'll just leave it there. But I think we'll be needing a NOT value for W, X, and Z. So I'll just have them all uh, have NOT values. So here, W, X, and Z. Now let's first get X prime Z. So we could get that by getting this value, X prime. So this is X prime. Now Z, which is this one. So we'll get this. Now let's move on to W prime X Z prime. So W prime, which is this value, and then we have X, simply X. So I could get that using this. And since we don't have space for our third input, we simply move to the next pin, which is next closest pin. So this two inputs is now equal to W prime X, and we move it here so that we could add Z. So Z, which is this one. Actually, we'll need Z prime. So it'll just be I'll just extend this. Okay. Now since we've already done this, let's move on to WX prime. So this is W. Now let's look for X prime, which is these one. X prime. And we get it here. Now since we've I've actually made a mistake since I've put it in RVCC. So let me just adjust that. And since we've filled our uh, first IC here, let's get another one, which I already placed here. So we'll be creating our last part, which is WZ. Now first, let's get the W. Wait, I'll just W, then Z. Now we'll have this output. Now, in order to wait, just rewrite that. There. So let me just get another and IC. Now let's have this. Now since we've done all the parts that needed to be ended, let's now move on to the OR IC. So let's first find our X prime and Z prime, which is this one, X prime and Z prime. And now let's have our WXZ. So this is our W. This is our W prime, X. And then this is our Z prime. So this is our, let's just add this here. Now let's just add here. And add another one, which is our WX prime. So this is our W. This is our X prime. This is its result. Just simply add it here. And I just actually move it here? There. Now we need our last one is WZ, this one. And we have our output here. Now we've done our circuit. We could compare it to the truth table I've created here, and we should get the values. And if we did not, let's check for errors. So we simply get or check by using the project tab, analyze circuit option, then uh, we get this table. Now comparing the values, we have 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1, and then 4 ones and 0, 1. Now to check more, let's compare our table here with the minimize option. And as we can see, we've done it correctly. Even the equation, so x prime z plus w prime x z prime plus w x prime plus wz. Now we're done with our number 5. So let me just save this file. Save. Now let's move on to our given number 6. So for our number 6, um, we are given the K-map driven drive the equation and implement in Logism. So we simply do what we have just done in question number uh, question number 5. So let's first start off with the group, which is the pink group. So as we can see, for A and B, we have 0, 0, and 1, 0. Since A has changed, we omit A and put B prime since 0 is not equal to 1. Now let's compare the CD, 0, 0, and 1, 0. Since 0 changes from 0 to 1, uh, we cancel C and now compare D, which is 0 and 0. So we get D prime. Then move on to the next group and add plus, which is this one. This is the next group, and since we've actually have the AB here and 0, 0, we simply add A prime, B prime, then move on to the next group. Oh, I actually forgot to put CD. So since comparing 1, 1 and 1, 0 here, we get C. And since 1 changes to 0, we omit D and then move on to the next group. Now we have our green here, green group, which is these area. So 1, 1, and 1, 0. Now to start off, we have 1 and 1, so we get A. Now we have 1 and 0, so we omit that. And 1, 0, since we have no number to compare it to in CD, we simply put C and then D prime. Then plus. Now the last group, we have 1, 1. So we automatically put A and B. Then we have 0, 1 and 1, 1, 0, 0 compared to 1. We have omit. We have to omit C and then compare D, which is 1, 1. We have D. Now, as I've seen earlier, we have this, and we can compare the values, and we are so far on the right track. So let me create a circuit. So we have it here, BD plus A prime, B prime C, ACD prime, and ABD. So we'll be needing a B prime, D prime, A prime, and B prime, and not a C prime. Is that correct? Yeah, we'll not be needing a C prime. So I'll start off by simply putting A, B, and then D. Now let's first start off with our B prime D prime. So this is our B prime. Then we'll be needing our D prime, just this one. Now we have our end, first end. Now let's move on to our second one, which is A prime, B prime, C. So A, now we need B, so I'll just delete that. Delete this, B. And since we don't have enough space to get C, let's just move it, connect it here, B. Now let's get our C, which is this one. So actually I'll just um, put it here. There. So let me delete this. So we're done with our A prime, B prime, C prime. And I think we've encountered a problem since we've only acquired this blue line, which may cause errors later on. But let's just continue with our circuit. So we'll be needing um, ACD, and I think it will not fit here anymore. So let's just move on here. So we'll need an A, let's just move this one, A, then a C, then a D prime, which we could not add since we only have two inputs here. So let's first move it here, there, then D. Now we have done our third part. Let's move on to A, B, and D, which could be done here, A, then B, then finally D. So we could do that by simply putting this input here, then proceeding to D. We have our result here. So to actually remove this error here, I'll just save it first, then reopen it. So let's open the file again. Open lab2. So question 6. See, now it's okay. So let's analyze if we've already completed our ended operation. So B prime, D prime, A prime, B prime, and C, and then our A, C, and then D prime. Okay. Now lastly our ABD, which is this one. A, then B, and then finally D. Now let's connect it with the OR. So first let's have our BD. BD. Then we'll need our A prime BD prime B prime D prime here. Now we'll need our A prime B prime C, which is this one. I'll just connect this input here, and we'll have to add our AC D prime, which is this one. And we have our input here, and since we don't have space anymore, let's just connect this one again. Right. Here. And then I'll have the last one, which is the ABD here. And we get this output. Let's connect it to F. There. Now to check if we have errors, we've committed errors, let's first analyze our circuit. So we've actually analyzed it, and now we could compare the table we have with our given, or with the table I would have created. In order to make sure that we've done it correctly, we just check. So 0, 0, we have 1, 0, 0, 0, 1, we have 0, 0, 0, 1, 0, we have 1, 0, 0, 1, 1, we have 1. So this, all four of this are correct. We got this correct. Now we have 0, 1, 0, 0, which is 0, 0, 1, 0, 0, 1, 1, 0, we have 0, 0, 1, 0, 1, 0, and 0, 1, 1, we have 0. Now moving in to our 1, 1, 0, 0, which is this one, we have 0. Now 1, 1, 0, 1, 1, and 1, 1, 1, 1, we have 1, 1, 1, 1, 10, we have 1, and then our last 4, 10, 0, 0, 1, 10, 0, 0, 1, 0, and 10, 1, 1, 0, and 10, 10, we have 1. So we could also check it using the minimize tab, and as you can see, we've done it correctly. And compare this: B prime D prime, B prime D prime, A prime B prime C, A prime B prime C, A C D prime, and A B D. So that's it for question number 6. Now let's actually move on to our question number 7, which is this given. So derive, I've actually spelled this wrong, simplified canonical form. So what I've actually done is assign them to 3 groups separated by the plus. So we'll be converting it to SOP canonical form. So I've actually want to start with the first group, which is the orange group. So let's put it here. x, y. Now we go to x, y, and as we see, we have three variables, x, y, z, and x, y has only two variables, and we have z, which is nowhere to be found. However, z is equal to 2 raised to 1. Thus, we have the variables 0 and 1. And as you can see, 0 is represented by z prime, and 1 is represented by z. Thus, we get xy is equal to xy z prime plus x y z. Now let's move on to our second part, which is the yellow part. I'll just put it here. Yellow. Now we have x prime z. Let me just add this equation. I'll just simply put what occurred first here. Xy times z prime plus z. There. That's what we've actually done in this part. We've actually distributed it. Now here, for our second part, we have actually a missing term, which is y. So y question mark, and as we've discussed earlier, we have two outputs, 0, which is represented here as y prime, and 1, which is represented here as y. Now, with that, we could say that x prime z is ORed by y prime ended y. Now with that, we distribute it and we get the value x prime z y prime plus x prime z y. Now, in order to achieve uniformity, we could just simply rearrange and get the values x prime y prime z plus x prime yz. Wait, I'll just highlight this so that we do not forget that these values are our answer. There. Now let's move on to our third, which is y prime. Now, unlike the two we have before, we could see that there are two variables missing. So we have x, and then we have our let's call this z. Now now we know that 0 is represented by x prime, while 1 is represented by x. And we could also conclude that here, however, here we have z prime. And here we have z. Now, distributing y, we have this function x plus x. We actually get x prime y plus, oh, I forgot the prime. Wait, y prime plus x y prime. Now, these values will actually, let's see, distribute to our variables z prime plus z. There. Now we get the values. We will get the values x prime, y prime, z prime plus x prime, y prime, z plus x, y prime, z prime plus x, y prime, z. So we simply add these variables together. So let me just control C. Let's just copy this, control C, control V. Wait, I'll just have it here, control V, control C. Then here, control V, there. And I'll move this, control C. There. And I'll move this downwards, control X, control, there. Now we get this value for the simplified canonical form. And as we could see, I'll just copy it here again. Control V. Wait, I made an error. C. Control C. Control V. And then this one, Control C. Control V. So for this part, we'll be actually needing to see if the variables have high frequency. So let's first look for XYZ prime, just this one. So let's change that to orange. XYZ, which is XYZ, this one. Let's change that to orange as well. Now X prime, Y prime, Z, which is this one. Let's change it to yellow. X prime, Y, Z, which is this one. Let's also change that to yellow. Now we have this for blue, X prime, Y prime, Z prime, blue. Now we have X prime, Y prime, Z, X prime, Y prime, Z, which is also this one. So we just change this since they are similar values. Oh, I meant this one. It's this one. Now let's move on to X, Y prime, Z prime. X, Y prime, Z prime. And finally, xy prime z. Xy prime z. And as you can see, the only variable left is 0, 1, 0, which is 0. Now let's check if we've done it correctly using Logism. So as we can see, we have used the not for all. So let's just proceed to having them all have not values. Okay, now let's first proceed to our first variable, which is x, y, z prime. So let's first add that x. Wait, I'll just move it first. X, y, and then z prime. So we've already need this one, x, y, z prime. So now, oh, I made an error. Since we only have two inputs for this IC, we need to place it to the next one. So here, there. Now it's green, so we've done it correctly. Now we're done with our XYZ prime. Let's proceed. Wait, I'll just put it here. Now let's proceed to our XYZ on the other side. So X, Y, then connect it, this one, this output here, since it is not allowed. Now Z for this one, Z. Now we have our first two, which is XYZ prime and XYZ. Now let's move on to our third one, which is the yellow group. So we'll be needing not X. Wait. Not X. Then not Y. Then Z. Z. We have our result here. Now let's move on to our fourth answer, which is X prime, which is this one, I think. Yeah, this is Z prime. Let's just connect it here. And then Y prime, I mean Y only. And I'll actually deleting this one first. Prime, Y prime. Then our Z. Which is this one. Oh, made an error. Wait, actually made the errors here. So yeah, let's just move this here. Then that. Then, and there. Now let's move on to our fourth one. So our third one, which is x prime, y prime, z prime. X prime, this one. Okay. Y prime, which is this one. And then our z prime, which is this one. Okay. Now we're done with that. Let's proceed. I'll just add this pala. Here. Our first output. Now we'll be needing x prime, y prime, z. So let's just put it here. X prime, y prime, and then z. Am I correct? Yeah, z. Then the output will be here. Now let's put on our x, y prime, z prime for our x. Okay, x, and then y prime, y prime. This is our y prime. Let's check y prime. Yes, this is our y prime. Connect this here. I forgot, since we've actually we've actually done this one, the second one. So we could actually skip that part and proceed to wait, I'll just change this one. This is our x prime, y prime, z prime, and let's just change our x. Then delete and have our x here. X prime, x, y prime, z prime, z prime is this one. There. Now our third and our fourth and last xyz. Okay, x, y prime, and then z, which is this one. We actually have an output here. There. Now it's time for our OR gate. So I'll just need to turn this south. There. First connect these ones. Connect it here. There. And then this one here. Let's turn this out as well. Then we'll have to put this one here. Now we'll have to have our x prime, y prime, z prime here. And then x, y prime, z, x, which is this one. Wait, I'll just check. X, y prime, and then z prime. So yeah, this one's correct. Now let's have our result here to be ORed. Here, and then this is our last one, and we actually get this value. There. Let me just minimize this one for you. There. So in order to check if this is correct, let's test it. So first, 0, 0, 0, we get a value of 1. So this is correct. And then 0, 1, 0, wait, I'll just change here. 0, 1, 0. So we get a value of 0. Thus, we also get this correctly. 1, 1, 1. 1, 1, 0, I meant. So let's just change this to 1. 1, 1, 0, 0, 1. So these two are correct. Wait. Color. Yeah, there. Now let's move on to 0, 0, 1. 0, 0, 1. 1 as well. 0, 1, 1. 1 as well. And 1, 1, 1, 1. 1 as well. And 1, 0, 1. 1 as well. So we've actually gotten the correct results or the desired results. Let's just check our circuit, and um, we actually get this table. So as you can see, we only have 1 0, which is for 0 1 0, as we've seen in our table and as we've projected a while ago. Let's see our this is what our table would look like if we have it. And this is a shortcut or the simplest expression, which is y prime plus z plus x. Now we're done with number 7, and so that's all for today for questions 5, 6, and 7. So thank you for listening.